The force of gravity is, the symbol for it is F sub g, for the force of gravity. The force of gravity is synonymous with something else that you have heard of before, and that is weight. So force of gravity and weight mean the same thing. The equation for the force of gravity is mass times the acceleration due to gravity. The force of gravity equals the mass times the acceleration due to gravity, and this is a boxed equation, where m is the mass of the object, and g here on planet Earth, Mitch, is what? 9.8 meters per second squared. Is that a positive or a negative number? Are you positive that that number is positive? You are positive, all right. Ladies and gentle people, here on planet Earth, the acceleration due to gravity is 9.8 meters per second squared, and it is positive. What is the direction of the force of gravity? Connie? Down. Notice, whenever you take an object and you drop it, it goes down. That's because the force of gravity is down. Now, two terms that are, oh, actually, let's do this first. The force of gravity, what are the dimensions on force then? If the force of gravity equals m times g, the mass times the acceleration due to gravity. Laura, work it out. What are the base SI dimensions for mass?
Grams or kilograms?
Which one is it?
Kilograms?
Kilograms. Base SI dimensions for mass are kilograms. And then the dimensions for the acceleration due to gravity, Laura?
Meters per second squared.
Meters per second squared. So, the force is in kilograms times meters per second squared, or kilograms meters per second squared, and that is called a Newton, or a capital N for newtons. And this is after a gentleman whose three laws we're going to start learning about today. Sir Isaac Newton, mid-1600s, came up with his three laws. We're going to talk about those today. So force of gravity, the weight is in newtons, which is kilograms times meters per second squared. Now, we have two terms on the board which we need to make sure we understand the difference between. Weight versus mass. These two terms are often used interchangeably, and you need to know that they are not interchangeable. They mean very different things. And we're going to highlight the three main differences between weight and mass. Please give me, Ms. Hong, a difference between weight and mass.
Weight is different with the force of gravity because when the force of gravity changes in mass is constant.
I'm sorry, say that again. When the force of gravity changes.
Weight also changes, but then mass doesn't.
Okay, so why would weight change? I forgot your purse. I'm sorry. I just got that on my back. I'm sorry, say that again. I'm trying to understand.
Because weight is force of gravity acting on an object, but mass is not.
Because weight is the force of gravity acting on an object, but mass is not. Unfortunately, isn't quite enough for me. I think you were getting to something which is true, but we're not quite there yet. Who can give me something about the difference between weight and mass? You can continue on that. It's fine either way. Andy.
As gravity changes, the weight will change, but the mass will stay the same.
What do you mean gravity?
G.
Okay, now you need to be careful. Now that I've introduced the force of gravity, you guys have this tendency to refer to something called gravity, which isn't a very descriptive term. You need to either refer to the acceleration due to gravity, which is little g, or the force of gravity, which is the weight of the object. So try again, and remember the force of gravity and the acceleration due to gravity are two different things.
So the acceleration due to gravity changes, then the weight will change, and the mass will stay the same.
So notice that weight is what is called an extrinsic property, whereas mass is what's called an intrinsic property. The weight depends on where you are, because where you are will change the acceleration due to gravity. So weight is an extrinsic property, whereas mass is an intrinsic property. In other words, mass is not dependent on external variables, whereas weight is. Weight is dependent on the acceleration due to gravity, and if we were to go to a different planet, your mass will stay the same, but your weight will change. If we go to the moon, again, your mass is going to change, or mass is going to stay the same, but your weight is going to change. Okay, that's one of the differences between weight and mass. Who's got another one for me? Difference between weight and mass. Usually, oh good, Mary.
One's measured in pounds and the other's measured in kilograms.
I agree that one is measured in kilograms, that would be SI units. One is measured in pounds in English units. I agree with that, but I want to do stuff in SI units. So we have mass in kilograms, and we have weight, rather than in pounds, we have weight in what, Sam?
What?
Right. We have weight. What are the dimensions for weight in SI units? I can almost hear you. It's so close.
That was kilograms.
Kilograms, no, that, remember that's mass. That's not weight. Connor? It's in newtons. So they have very different dimensions. Weight is in newtons, which is kilograms times meters per second squared, and mass is in kilograms. The third difference between weight and mass. Here's my hint for the third difference between weight and mass. Nick?
Weight is gravity pound.
I agree with that, and the key term there is down, gets to the difference between weight and mass. Josh?
Weight is a vector.
And mass is?
Scalar.
Weight is a vector. It has both magnitude and direction. Whereas mass is a scalar. It has only magnitude. So there are major differences between weight and mass. So class, are weight and mass the same thing?
No.
No. Please remember that. Weight and mass are not the same thing. They are very different items.